At 8 a.m., a Russian task force executed what looked like a perfect ambush against a NATO carrier group. They had the speed with hypersonic missiles. They had the element of surprise hidden behind commercial shipping lanes. And they had the firepower to sink a billion-dollar vessel in under 90 seconds. But by 8:05 a.m., their radar screens went black. Their missile guidance systems lost lock, and their engines died. They hadn't been fired upon with explosives. They had been lobotomized. Today, we are decoding the system of systems, the invisible digital spiderweb that turns the ocean's deadliest predators into helpless targets. This is not science fiction. This is the new reality of modern naval warfare. For decades, we have been taught that naval war is about who has the biggest gun or the fastest missile. We obsess over caliber and speed. But the latest declassified encounters and war game simulations from the Arctic to the Black Sea reveal a different truth. The old war was about kinetic energy. The modern war is about who controls the electromagnetic spectrum. If you can blind the enemy's sensors and silence their communications, their hypersonic missiles become nothing more than very expensive flying telephone poles. To understand how this invisible war is fought, we have to look at the changing face of the enemy. It is no longer just a gray warship on the horizon. It is a trap disguised as commerce. Consider the incident involving the vessel Volga M. At 8:42 a.m. on January 26th, the false calm over the Mediterranean was shattered. A French naval helicopter approached what appeared to be a standard oil tanker flying a civilian flag. It was a routine inspection of a suspected smuggler. But the Volga M was a Q ship, a vessel from the Shadow Fleet converted into a floating weapons platform. When the helicopter hovered over the deck, the tarp didn't just blow away. It revealed an AK-630 rotary cannon. In less than 2 seconds, a barrage of 30mm bullets tore through the air at a rate of 5,000 rounds per minute. The helicopter was destroyed instantly. But the trap was deeper than just one gun. As soon as the firing started, 3 other nearby cargo ships turned off their transponders and drifted into a blockade formation. These weren't just blocking the path. They were shielding the Volga M, which carried Club K cruise missile systems disguised as shipping containers. This is the nightmare scenario for a standard naval commander. The enemy is hiding behind hostage. The Volga M was filled with crude oil. If the U.S. Navy retaliated with a standard missile strike, they wouldn't just sink the ship. They would detonate an ecological bomb, causing a massive oil spill that the enemy would blame on NATO aggression. It was a perfect checkmate. Physical force was useless because the consequences of using it were too high. The enemy relied on hesitation. They relied on the gray zone of international law. But the U.S. Navy didn't use a missile. They used the spectrum. 2 EA-18G Growlers launched from the USS Gerald R. Ford over the horizon. They didn't carry bombs. They carried next-generation jammer pods and a high-power microwave weapon. They initiated a spectral surge. Instead of targeting the hull of the ship, they targeted the microchips inside its weapon systems. The microwave energy swept across the Russian formation like an invisible storm. It penetrated the cracks in the containers and overloaded the capacitors in the missile guidance systems. On the bridge of the Volga M, the screens didn't just flicker. They fried. The semiconductor circuits of the AK-630 cannon were cooked instantly. The ship was still floating. The oil was safe, but the weapons were dead. This is the definition of a soft kill. We didn't need to sink the ship to win the fight. We just needed to delete its ability to pull the trigger. This brings us to the second pillar of modern defense, the God Eye, or what military strategists call parasitic tracking. In the Arctic, the Russians have been testing NATO defenses with their 2 160 White Swan bombers. These are massive nuclear-capable aircraft designed to intimidate. On January 25th, 2 of these bombers approached Norwegian airspace with their transponders on. It was a public roar, a deliberate provocation to see how fast NATO would react. They expected a loud response. They expected American fighters to light up their radars, to lock on and reveal their frequencies. But they encountered silence. 2 US F-35 Lightning II fighters were already in the air, but their radars were in receive-only mode. This is the terrifying reality of passive detection. The F-35s were using the Russian bombers' own radar emissions to track them. Think of it like a burglar shouting in a dark house to see if anyone is home. The homeowner standing silently in the dark knows exactly where the burglar is because he won't stop yelling. The Russian pilots believed they were safe because their radar warning receivers were silent. They thought the sky was empty. In reality, they were already pinned to a digital map shared across the entire NATO network. The U.S. Navy didn't need to emit a signal to see them. They just needed to listen. This silence is lethality. In modern war, if you turn on your radar, you die. You become a beacon for every anti-radiation missile in the theater. The F-35s created a geometric lock on the Russian bombers from 20 kilometers away without ever letting the enemy know they were there. It is a psychological weapon as much as a tactical one. The enemy is flying blind while we are watching in high definition. But what happens when the enemy tries to break this lock? What happens when they stop playing games and start shooting? This is where the spectral surge goes from a defensive measure to an offensive weapon. During that same Arctic encounter, the Russian bombers eventually attempted to open their bomb bays. In the world of nuclear deterrence, an open bomb bay is considered a direct act of hostility. NATO had exactly 180 seconds to respond before cruise missiles could be released. Again, the response was not an explosion. An Arleigh Burke-class destroyer patrolling below unleashed a focused beam of energy directed not at the pilots, but at the aircraft's data bus. The Aegis combat system focused every kilowatt of energy onto a single microscopic frequency, the digital link that controls the bomb bay actuators. It was a surgical digital lobotomy. The American AI flooded the Russian system with a close command millions of times per second. The Russian pilots were frantically hitting their manual override buttons, but the doors wouldn't respond. They were caught in a loop of vibrating steel and digital white noise. The giant had its mouth open, but the U.S. Navy had just wired its jaw shut. The bomb bays remained jammed, not by mechanical failure, but by electronic paralysis. This technology changes the fundamental calculus of war. We often hear about Russia or China developing hypersonic missiles that travel at Mach 5 or Mach 8. The media loves to report that these weapons are unstoppable because they are too fast to shoot down. But speed is irrelevant if the weapon has no brain. A hypersonic missile relies on complex AI and sensors to find its target. If you can cook that brain with high-power microwaves or jam its sensors with electronic warfare, it doesn't matter how fast it's going. It just becomes a piece of debris falling into the ocean. Smart beats fast every single time. However, the technical architecture behind this capability is far more complex than a single jammer pod or microwave beam. Modern naval combat operates on layered architecture: space, air, surface, subsurface, and cyber all fused into a real-time combat cloud. The Carrier Strike Group is not a formation of ships. It is a distributed sensor grid. Each platform acts as a node in a constantly updating network that shares targeting data in milliseconds. At the center of this architecture is the concept of cooperative engagement capability. Every radar contact detected by one ship can be instantly shared with another. If a destroyer sees a target over the horizon, its fire control solution can be transmitted to a cruiser 50 miles away, which can launch a missile using data it did not generate itself. The missile never needs to see the target until the final seconds. The network sees for it. The Aegis combat system functions as the brain of this fleet organism. Its Spy Series phased array radars do not rotate like traditional radar dishes. They steer beams electronically at near light speed. Thousands of transmit-receive modules operate simultaneously, allowing the radar to track hundreds of targets while guiding interceptors. But even Aegis is evolving. The newest variants incorporate gallium nitride semiconductors that increase power efficiency and heat tolerance. This means stronger beams, longer detection ranges, and improved resistance to jamming. Electronic warfare today is not simply noise generation. It is precision waveform manipulation. Instead of blasting broadband interference across a spectrum, modern jammers inject tailored signals that mimic legitimate radar returns. This technique, called digital radio frequency memory, allows the jammer to capture an incoming radar pulse, modify it, and retransmit it with altered timing or amplitude. The enemy radar sees phantom targets. It sees ships where none exist. It sees empty ocean where a carrier actually sails. High-power microwave weapons operate on a different principle. Rather than confuse sensors, they physically damage electronic components. A microwave pulse induces currents inside microcircuits exceeding their voltage tolerance. Transistors overheat. Capacitors rupture. Logic gates latch permanently. Unlike a kinetic strike, the platform remains structurally intact, but its nervous system is fried. Repair requires complete replacement of sensitive electronics, a logistical nightmare in combat conditions. Another critical dimension is cyber-electromagnetic integration. Modern warships rely on complex, software-defined networks. Fire control, propulsion management, radar processing, and communications are interconnected through fiber optic backbones. If an adversary gains even limited access to these networks, they can implant malicious code designed to activate during combat. A missile may launch seconds late. A radar may reboot at the worst possible moment. The future battlefield includes invisible code dormant inside hardware long before hostilities begin. Satellite constellations add another layer. Positioning, navigation, and timing signals from space synchronize every system. But reliance on satellite navigation introduces vulnerability. Jamming or spoofing GPS signals can cause missiles to drift off course. To counter this vulnerability, modern munitions integrate inertial navigation systems hardened against external interference. Some combine celestial navigation algorithms using star tracking sensors as backup. The battle for space superiority is inseparable from naval dominance. Undersea warfare is also transforming. Submarines are no longer just torpedo platforms. They act as stealth sensor nodes, deploying unmanned underwater vehicles that extend detection ranges. Fiber optic tethered drones can map enemy formations without exposing the host submarine. Acoustic stealth remains essential, but digital silence is equally critical. Submarines now manage electromagnetic emissions with the same discipline as surface ships manage radar output. Artificial intelligence plays a decisive role in managing this complexity. Human operators cannot process the torrent of data generated by multi-domain sensors. Machine learning algorithms classify radar signatures, identify anomalies in electronic emissions, and predict adversary maneuvers based on historical patterns. Decision cycles that once required minutes are compressed into seconds. The side that processes faster wins. Hypersonic defense specifically demands layered interception strategies. Early warning satellites detect thermal plumes during launch. Over-the-horizon radars track mid-course trajectories. Terminal phase defenses include both kinetic interceptors and directed energy systems. Laser weapons mounted on destroyers provide rapid engagement capability against drones and small craft. Although atmospheric distortion limits range, adaptive optics compensate in real time. Energy weapons offer nearly unlimited magazines, constrained only by power generation capacity. Power generation, therefore, becomes strategic. Modern destroyers integrate gas turbine engines not only for propulsion, but also to drive advanced generators. Future surface combatants are exploring integrated electropropulsion, where a common power grid feeds both engines and weapons. This architecture allows rapid reallocation of power between propulsion and directed energy, depending on combat needs. In essence, the ship becomes a floating power plant optimized for electromagnetic warfare. Logistics remains the hidden backbone. Sustaining high-energy operations requires fuel, maintenance, and component replacement. Gallium nitride modules, microwave emitters, cooling systems, all demand supply chains resilient against disruption. An adversary targeting logistics hubs can indirectly neutralize advanced capabilities. The supply chain war extends from semiconductor fabrication plants to naval fuel depots. The drone swarm threat amplifies this challenge. Autonomous drones equipped with simple guidance systems can overwhelm radar tracking capacity. Counterswarm doctrine therefore integrates electronic attack, directed energy, and decoy deployment. Some systems launch small interceptor drones carrying microwave emitters to disable multiple hostile units simultaneously. Others deploy electromagnetic pulse munitions that create localized electronic blackouts. Decoys remain essential. Inflatable radar reflectors, electronic emitters mimicking carrier signatures, and expendable off-board active decoys create false targets. The objective is to stretch the enemy's targeting algorithm beyond reliability. Every missile fired at a decoy is one less threat to the fleet. The human factor persists despite automation. Commanders must decide when to remain silent and when to emit. Emission control discipline determines survival. A single unnecessary radar sweep can reveal position. Training now emphasizes cognitive restraint as much as aggression. The captain who resists the urge to react impulsively may save the fleet. However, we must address the gap in this narrative. Is the U.S. Navy invincible? Not exactly. The danger in the future isn't just the sophistication of the missiles. It is the cost. Consider the recent defense of Ukraine. In a single night, Russia launched 12 Iskander ballistic missiles. Ukraine shot them all down using a layered defense of Patriots and S-300s. It was a perfect defensive victory. But then came the second wave. It wasn't missiles. It was a swarm of 200 cheap autonomous drones. These drones cost a fraction of a single Patriot interceptor. Russia spends pennies to launch them, while the defenders spend millions to stop them. This is the supply chain war. The enemy doesn't need to blow up the carrier to win. They just need to bankrupt us trying to defend it. If we have to fire a $2 million missile to stop a $20,000 drone, we lose the war of attrition. This is why the future isn't just about the spectral surge or the high-tech jammer. It is about the counterswarm. The shift from expensive kinetic interceptors to directed energy weapons that cost pennies per shot to fire. The microwave weapons used on the Volga M and the White Swans are not just effective, they are sustainable. They don't run out of ammo as long as the ship has power. So where does this leave us? The ocean is no longer just a physical battlefield. It is a network of sensors, data links, and energy beams. The ultimate weapon in the 21st century isn't the one that makes the loudest bang. It is the one that ensures the enemy never gets to pull the trigger. It is the nerve of a captain like Commander Stone of the USS John Paul Jones who stared down a Russian destroyer and refused to blink because she knew the laws of physics and the laws of nations were on her side. Russia and China are betting on mass and speed. They are building faster missiles and more ships. The West is betting on the network, on the ability to turn the enemy's sensors against them and to disable their weapons before they leave the tube. The next time you see a headline about a terrifying new hypersonic weapon, remember the silence of the Arctic. Remember the open bomb bays that wouldn't release. And remember that the deadliest weapon is the one you never hear coming.